So for those of you watching on YouTube, the class just finished writing the Google Forms test, which is linked in the description along with a hint for questions 13 and 14 and also a note about questions 7 and 11. So when you finish the test, do judge yourself out of 36, not 40, until after you've watched the review, which we'll discuss questions 7 and 11 in more detail then. All right. So let's get started with the review. I think some of the questions should have been quite familiar to you, but let's see. Okay, so let's just get right into it. So question 1, you are developing code for a method that calculates the discount for the items sold. You name the method calculate discount. The method defines a variable percent value of the type double. Okay. You need to make sure that percent value is accessible only within the calculate discount method. What access modifier should you use when defining the percent variable? Would I have to tell you guys this one? I think this one's pretty straightforward, right? What do we think? So the options are private, protected, internal, and public. They are usually a little bit tricky with the wording, I think. But this one, what's the big thing here? So it's a question about encapsulation, right? Because we say you need to make sure that the percent value is accessible only within the calculate discount method. So we want it to be only accessible within a specific place, right? Exactly. Okay, cool. So that one's good. Yeah. Private is the answer there. Yeah, good stuff. All right, this one maybe also not used to how you're being asked about this concept, but again, I would say maybe not too bad. So you are developing code that defines an init fields method. The method takes two parameters of data type double and does not return any value to the calling code. Which of the following code? Okay, so Christian says B, and yeah, that is right, but let's go through it deductively so that we can see why the other ones are wrong, right? So they give us two things here. So there's two conditions that we have to meet. The method takes in two parameters, okay, of type double, and also it does not return any value to the calling code. Okay, so those are the two ideas that we need to meet in this code. So of the options they give us, let me maybe zoom in even a little bit more so that you guys can see more clearly. Okay, so in option 1, immediately we can see why this is wrong, even just reading the first two words. Okay, so it says public double, all right, but this says it must not return any value to the calling code. This code returns a double, right? That should be void. The other way to see that it's wrong is that inside the method it says return length times width. So this is returning something, so that's wrong. Okay, the second one, we can see public void init fields double L double W, length equals L, width equals W, and it doesn't return anything. So this seems pretty sensible. Okay, C, we see that it only takes in one thing, right? So public void, that's great. Init fields, cool. Double L, there's no second double. And this specifically tells us that it needs to take in two parameters, right? And then the third one, we have public double init fields double L double W, and we can immediately see it doesn't say void here, right? So it doesn't return anything this time, but it doesn't say void. Okay, so yeah, B is correct there. Again, not too bad, right? This is where some of you might have, because the wording gets a bit strange. So you created a class named GeoShape. You define a method called area in the GeoShape class. This method calculates the area of a geometric shape. All right, so we have a method that calculates the area that we're familiar with, actually. We've seen classes that have methods like this, right? You want the derived classes of GeoShape to supersede this functionality to support the area calculation of additional geometric shapes. So what they're saying there is we have, say, a class that has a method that calculates the area of a rectangle, for example. But we want to, so they say supersede here, we want to change that functionality so that maybe in one of the derived classes we could instead calculate the area of a triangle or any other shape that we have. Okay, So when the method area is invoked on a geoshape object, the area should be calculated based on the runtime type of the geoshape object. Okay, don't worry too much about this yet. Which keyword should we use when we define this method in the geoshape class? Okay, so actually, so what I want to point out to you guys, I did mention at the beginning that you should refer back to the multiple choice test that we did a while back. Okay, because this question 3, is the same as question 2. It's literally identical, except some of the names are changed. Okay, the names of the different things have changed. So we're talking about different classes, but the idea being tested here is identical to question 2 of the multiple choice we did a while back. Okay, so let me see. So let's go through it deductively again. Okay, so this question is about what we would call polymorphism, right? So we want to be able to override, supersede the functionality of previous of our base classes, okay, where we inherit from. So there's a few keywords that we should make note of, right? So overrides, this is wrong, right? They were trying to trick you here. The word is override. So even if this was the answer, this would be wrong, right? Because of that S there, they're just trying to throw you off. Okay, and I've told you before, and new we don't use in this context, right? New we can use in the derived class, but we don't use it to define. So it says which keyword should you use with the definition of the area method in the geoshape class. Okay, so we don't use new when we're defining methods. Okay, we would use abstract or virtual. Does anyone want to post in the chat? Do you guys remember what the difference between these two words was? Okay, Alex says B on this one, and yeah, that's true. And hopefully you guys can see the similarity with question 2 from the multiple choice we did a while back. So we have discussed this idea quite a lot, I think. But the difference was, so I'm just going to say it in words now. So the difference is abstract does not allow us to define a body for the method. So you see here where they say, you defined a method called area in the geoshape class. This method calculates the area of a geometric shape. So the fact that the method inside our base class actually does something means that that method could not have been abstract. It has to be virtual. Okay, so that's what that question there is asking. We did also discuss it more in the section 2 knowledge assessment. Okay, that multiple choice test. Cool. So question 4. Suppose that you defined a class scenario that defines functionality for running customized pivot transform on large data sets. We don't even need to know what that means. The point is we have a class that does something. Okay, it has some functionality. You do not want the functionality of this class to be inherited into derived classes. Okay, so this is the big thing for us, right? What keyword should you use to define the scenario class? Okay, so the big thing here is that we do not want it to be inherited. Okay, and yeah, Alex, you say A, and that's 100% correct. Again, I'm just going to quickly discuss the other options. Okay, yeah, exactly. It makes it not inheritable. Precisely, yeah. So I'm going to discuss the other options just in case anyone's. So this question is about inheritance, right? As Alex sort of mentioned here. Okay, so when we see words like private and internal, we can immediately ignore those, okay? Because those are about encapsulation. They're not about inheritance. All right. So we have two options here: sealed and abstract. Abstract, I am just going to go through it quickly here. Abstract means that it can only be inherited from, right? You can't create an object and you can't create an object of it directly, okay? And sealed means that you can't inherit from it, okay? You can only instantiate it. All right, so yeah, the answer there is sealed. Good stuff. This one, I think it was you, Alex, as well. You literally got this question right. When we did the knowledge assessment. It's worded slightly differently, but question 5 is the same as question 4 from the knowledge assessment. Basically, it's slightly different, but it might not even be different. Okay, yeah, I think question 4 said query functionality, and this one says printing functionality. That's the only difference. So it says you need to provide printing. Oh, and by the way, guys, we didn't make up these questions. these questions are sampled from the MTA exam. Okay, so if you recognize these, that's a good sign, because it means you're probably quite well prepared. So you need to provide printing functionality to several of your classes. So we have a specific kind of functionality that we want to have in several different classes. Okay, printing functionality. Each class's algorithm for printing will likely be different. So they don't mention how different. Yeah, these are no. They're not. Remember, they have hundreds of possible questions to draw from, and they're only going to show you 35 of them. So obviously, the more questions you see, the better. But yeah, you will see questions very similar to these from exams. So these are past exam questions, and hell, they might be in your exam, right? They're randomly picked. Okay, but everyone has different questions in their test. Okay, so each class's algorithm for printing will likely be different. Also, not all the classes have an is-a relationship with each other. How should you support this functionality? Okay, so we did discuss this quite a lot in detail. It was D, create a common interface that all classes implement. The special thing that we had to note here was that it said should. Okay, it says how should you support this functionality? It's not saying how can you, it's saying how should you. Okay, so how would you do this professionally? It's not saying like, because if we look at B, it says have all classes inherit from an abstract base class and override the base class method to provide their own print functionality. B is technically possible. It's technically possible, but you should know from what we've covered in the course that the correct way to do this is with an interface. Okay, so B is technically possible, but don't let that throw you off. They're asking how should you do it. Okay. Cool, but also remember this is the same as question 4, so if you want more discussion of it, check out the knowledge assessment YouTube video. You are writing code for a class named book. You should be able to get a list of all the books sorted by the author's last name. Okay, we have a class named book and we want a method that does something. You need to write code to define this behavior of a class. Which of the following class elements should you use? A, method, B, property, C, event, D, delegate. Okay, so Alex says he thinks it's method. Yeah, and that's correct. But again, I think the benefit here, you guys already have seen that A is correct if you went through your exam together. Like afterwards, sorry, not together, but after you finished. So let's just discuss each option. So property, we know what a property is, right? It defines an attribute of a class. Like if you're defining a person class, you might have the number of legs as an integer, right? The number of legs that a person has. That's an attribute of the person, or the hair color, or the eye color, or whatever. They're attributes, they're not behaviors, right? Like the color of your eyes is not a behavior. A behavior is something like running, or jumping, or cooking something. All of these things would be behaviors. So property is not the answer, because properties are for attributes, not behaviors. Event. An event is like a list of methods to call when something happens, right? So the event shouts out, and it has a list of things to call when it shouts, right? So an event is more like a list of behaviors. You could even see it in that way, okay? But it's not a behavior itself. You wouldn't define the behavior of a class in an event, okay? Delegates is a signature for a method, right? It's not the method itself. So if you want more detail on this, the events and delegates video, probably watch that. But really, this should be quite intuitive to most of you. Yeah, method is where we define the behavior of a class, okay? Or a procedure, an algorithm, you know, any step-by-step process like we define in a method. All right. So next question. Suppose that you are writing code for a class named product. You need to make sure that the data members of the class are initialized to their correct values as soon as you create an object of the product class. Okay, quite a mouthful. The initialization code should always be executed. What should you do? Create a constructor in the product class to initialize. That is, yeah, exactly. Create a constructor. This question is the same as question 6 from the multiple choice test we did a while back. It's just that the words changed a bit. I think it might actually be identical. I'm not sure. I think it's actually identical. But yeah, so we've discussed this question exactly, so hopefully we don't have to spend more time on it. I think we went through every single option sort of 2 weeks ago, I think. Okay, this one we've also seen before. Again, slightly differently worded, but still should be similar to most of you. You are creating a new class named sphere derived from the shape class. The area method in the shape class should provide new functionality, but also, and this was the important bit, hide the shape class implementation of the area method. Which code segment should you use to accomplish this? Okay, so here I want to again do it deductively because I think it's pretty quick to do as well. So here static, that wouldn't be correct, right? The only thing that changes here is the word that we use after public, right? So public override, public new, public virtual, or public static. So you're basically picking a word. Which one of these words will what word do they use? Provide new functionality, but also hide the shape class. Okay, so which one will supersede the functionality, but also only hide it, not remove it, just hide it. Okay, so which one of these words will do that? Static will just allow you to use it without creating a sphere, right? Virtual is not, shouldn't, this is in the wrong place, right? Virtual is not the word we would use for this at all. We would use in the definition. We wouldn't use it when overriding. Okay, override, that doesn't just hide it, right? It replaces it. New will just hide it. Okay, so new is the correct answer there. Yeah, B. Good stuff, guys. Okay, you are creating a class named Polygon. You write the following code, and you need to complete the definition of the compare_to method to enable comparison of the polygon objects. Which of the following code segments should you use? So again, we've covered this in quite a lot of detail, I think, but let's just discuss it a bit now. Sorry, I do want to get through this part of the review because question 13 and 14, I want to actually program up and go through in detail. Okay, so let's just check out every single possible option, and for no apparent reason, let's start with option D first. Okay, so immediately when we look at option D, we can see it says if this equals target. Okay, so this and target are objects, right? We are looking to compare the area. So when you try to compare this to target, you're comparing two rectangle objects, but these are not numbers, right? This and target are not numbers. They're the entire object. Okay, if you said this dot length or this dot area or something like that, this would make sense. But you can't just compare the objects to each other directly. So this is immediately wrong, okay, because it's not even comparing numbers. This one here, same, right? This equals target. You're comparing objects here. Equals will only work with numbers, right? So option C and D, while they might trick you in that they could get the ordering correct, because they're comparing the objects themselves, it's not, don't let that trick you. Okay, so we're left with A or B, all right? And what's cool here is that we can actually eliminate one of them very quickly. Okay, so if you remember how to compare the difference of two things, right? If we say this dot get area minus target dot get area, if the areas of these two objects were the same, then the difference would be 0, right? So when we say if diff equals 0, that would mean that the two objects had the same area. Okay, and what number must we return when they have the same area, guys? If the two things that we're comparing are the same in the order, what number does C# expect us to return from the compare_to method? 0, 0, precisely, yeah. So which one of these does that, guys? Which one of these returns 0? If the is it, Alex? If the difference equals 0, it must return 0. So just look at that. Yeah, it's A. Okay. So look, so we see if diff equals 0, so this would mean that the objects are the same, right? So then it returns 0. This one, you see it says if diff equals 0, and there it says return 1. I agree with you. I'm not sure why. These images should definitely be .svgs. I think they're currently .pngs or something. So I will get them for the next one to make these higher res, because maybe it is a bit difficult to read. But yeah. So yeah, 0 there, 1 is returned there. So we can immediately see that it must be A, and you could check the other ones if you like. So if difference is greater than 0, that would mean that this area is greater than target area. Okay, so this comes after target in the order, which means we must return a positive integer. We just return 1 to keep things simple. And so there it returns 1. So we're still good on A. And otherwise it returns -1. So in all other cases, which would mean if this is before that in the order, this is before target in the order. Okay, so it's A on that one. And this is very similar to, if you want to see another discussion of it, I think we went more in depth the last time. Check out our discussion of question 8 in the last knowledge assessment. Okay. So you are writing code for a new method named process. All right, so we have some process method. That's cool. The code receives a parameter of type object. Okay. You need to cast this object into the type polygon. At times, the value of O that is passed to the method might not be a valid polygon value. You need to make sure that the code does not generate any system.invalid cast exception errors while doing the conversions. Okay, guys, so we have seen this question precisely, basically, and except with rectangles, I think, instead of polygons. So to some of you, this might have seemed very trivial, but what I think this is hammering home, which is good for you guys to know, is they love testing this. And the reason they love testing this is because C# specially added this word as to solve this problem. Okay, it's special. Oh, and actually, I remember, I think it was Maya who brought up last time, this one, I have played with it more, and it does work. It does stop invalid cast exceptions, and I think it's because of this tricky word use of the word should again. Okay, so how should you do this versus how can you do this? Okay, so when we're trying to do something like this in C#, we always use the word as because it was specially added to C# to solve this problem. Okay. Yeah, exactly. So always when you're looking at some question about casting, they love asking about as. Okay, so just look if as is an option, and it's probably the best bet, particularly if they say without generating invalid cast exceptions. And I mean, that's also another way to check, right? So if they say does not generate any system.invalid cast exceptions, you can pretty much guarantee it's going to be as. If they say it should generate system.invalid cast exceptions, perhaps, or you want to catch the exception or something, then you know that it can't be as. Okay, but these questions are pretty much always going to revolve around the word as, all right? But yeah, we also saw this last week, I think, with question 9, and now the questions become a little bit different because we've exhausted those options. Okay, so although this one is also quite similar. So you are writing code to handle events in your program. You define a delegate named polygon handler, and you also create a variable of the polygon handler type as shown below. Okay, and now the bit that matters. Later in the program, you need to add a method named calculate area to the method invocation list of the handler variable. Okay, so just see this as adding another method to call when the event occurs. Okay, that's what they mean by method invocation list. So list of methods to call when the event occurs, basically. See it that way. The signature of the calculate area method matches the signature of the polygon handler method. Any code that you write should not affect any existing event handling code. Given this restriction, which of the following code lines should you write? Okay, so one big thing here, so if you're looking for the easy way out on these kinds of questions, whenever you're adding a method to an invocation list, to any kind of event or delegate or whatever, or to a handler, you're always going to use plus equals. Okay, that's the standard. Yeah, that's the standard, and that's correct. Okay, and I know, so yes, 11, they didn't specify the correct answer. So if you did say C, then you got it correct. So you should add 2 to your mark. Likewise with 7, they didn't specify a correct answer. All right, 7, no correct answer was specified. So if you said B, you can add 2 to your mark here. Okay, if you said B, creates a constructor, you did actually get 7 correct. Okay, so yeah, sorry, I forgot to mention that. Yeah, but also you need a +4 to what it's out of, hey Alex. So it's no longer out of 36. So, yeah. So it's tricky, is it? But yeah, I mean that's good. You got 2 more right. That's better than just ignoring them, right? Okay, cool. So this question we have seen before. It was question 10 from the multiple choice test. We discussed it in detail there. It was basically just to do with what plus equals does. Okay, someone also asked about it. I think it was Alex in the chat earlier. So if you have an equal sign, you would totally overwrite the list held in handler, right? If you just make it equals, then handler would no longer have any other methods in its list. It would just be calculate area, okay? Or it would just be new polygon handler calculate area. If you say minus equals, that's obviously totally silly, right? It says in the question that you want to add a method named calculate area. No one would add something by putting a minus there, right? So the plus equals is a good. They also say add, right? When we add things, we use a plus sign. Makes sense, right? Okay, question 12. Now this one's a bit interesting. You haven't seen this before. Okay, you haven't seen anything like question 12 before. Hopefully some of you got it. I'm not sure. Bryanston struggled a little bit with it. So you are developing a C# application. You create a class of the name widget. Okay, so we have a class called widget. That's what they told us. You use some third-party libraries, so we're using someone else's stuff. And we have seen this before as well. Like if I go over into Rex Tester, we are using system here, right? It says using system. This is the third-party library. We have had this discussion before. So we're using someone else's code. Okay, so that's what they're saying here. You're using someone else's code. You need to make sure that using the widget class in your code causes no ambiguity. Okay, so which C# keyword should you use? Right, so let me frame this. Okay, nice. Yeah, so we say namespace. But let me explain this just a bit more. So what they're saying, just in case anyone doesn't get it, is let's say I have a class here called so there's a class we know, right? Called console, right? Whenever we say console.writeLine, this is a console class, and inside the console class we have a writeLine method, right? But let's say I want a class inside my code. I want to create my own class called console, like that. Right? Let's say I want to do that. I want to create my own class called console. Now system already has this console here is system.console, right? How does C# know not to be confused? The reason it knows not to be confused is because this console is in a namespace called system, all right? Whereas my console is in a namespace called Rex Tester. Okay, so the namespace is what allows us to have the same class name without any ambiguity. Okay, they worded it a little bit strangely here, but I'm glad some of you guys got it. So yeah, we use namespace, and the other words don't really make sense in this context as well. So you also probably could have done it deductively if you took some time on 12. Okay, we are running out of time, which is a bit unfortunate. So 13 and 14 are difficult. Maybe I should save discussion of these for next week. Okay, let's just do it, and I suppose we could just continue with the test next week and just finish our little review of it then. Or if you guys are okay with me going a bit over time and you guys watching the video if you need to go immediately. Okay, so you're reviewing the following C# program. What will be the output when this code is executed? Okay, so the big trick here, I think I want to program this out. So yeah, okay, let's leave 13 and 14 for next week, and we'll review those next week. Okay, because I don't want to take up more of your time now, because I know you guys have had a long day. Okay, so you're developing a C# application. You need to decide whether to declare a member as static. Which of the following statements is true about static members of a class? Okay, this is also quite a nice question that you haven't seen before. It might be a little bit confusing, particularly because we hadn't done extra reading on static. But let's look at them. Some of them are very easy to eliminate. Okay, so you can use the this keyword reference with a static method or property. So why is this wrong? All right. remember, okay, I accidentally clicked it. The answer is not A. So to say this, you're referring to an object, right? This object, the object you're currently working with, right? Like if you think about the compare to method, we have rect1 dot compare to rect2, and inside that compare to method, we can refer to rect1 as this, all right? In order to have this, we have to have an object. We have to have an object in order to have this. Okay, so static doesn't require you to have an object when using a static method or property, right? The static keyword means you don't need the object itself, right? So how could you use this if you didn't even have an object? So A is wrong. Okay. Only one copy of a static field is shared by all instances of a class. I think you guys might have seen this, but I wouldn't expect you to know confidently that this is wrong. But it is quite intuitive if I show it to you. So like if I create, so in my console here, in my console class, if I create a public static, I don't know, name or something, like any kind of property or whatever that is static, or method that is static. If I created multiple objects of type console, you wouldn't expect name to be shared across all of them, right? A different copy will exist for each one of those objects. Okay, so a little bit, you would have to really think about it to be confident on this one, because we haven't discussed that particular topic much in depth. But yeah, that one's not true. This one, C, I would expect you to be able to eliminate. Okay, static members of a class can be used only after an instance of a class is created. This is definitely false, right? Because this is literally the opposite of the definition of static. Okay, this is the opposite of the definition of the word static, and so the last one is true. Okay, the static keyword is used to declare members that do not belong to individual objects, but to a class itself. Okay, and that makes a lot of sense. That's why main, right? Main is static, okay, because it doesn't belong to this class. Okay, it's just it's where we run where we will begin running the code, where we will begin code execution is the main method. Okay, it's not unique to, I mean, it's not it's not owned by class program. I can call main without going and creating an object of type program, right? I don't have to say program prog equals new program, right? I don't have to do this before my code runs. We're able to run main without a program object. That's what static is for. Okay. Awesome. I think let's just do one more and then we can call it a day. I won't take up more of your time. And we'll finish reviewing the test next week. Okay, suppose that you are a new C# developer and reviewing object-oriented programming fundamentals. Which of the following statements is not true? Okay, I think it was Alex, you as well. You asked a question about this one. And this one's maybe a bit tricky. Okay, so let's see. So which one is not true? Okay, so we need to think not true. Okay, so let's start at the bottom. So a constructor is used to initialize the data members of the object. Okay, a constructor is used to initialize the data members of the object. That's true. Okay, D is true. We do use a constructor to initialize data members. Okay, a class is a definition of a new data type. This is actually true. Okay, so let me describe it to you like this actually. So I have defined a class this way before, but one way that you can clearly see this, that's quite nice, right? If I have class rectangle here, and let's say it has some properties, right? It has some stuff. It has all the stuff that we've seen in a rectangle class before. In fact, Alex, you can tell me, how would I create an object of type rectangle? Do you remember? If I wanted to create a new object of type rectangle, how would I do that? Or anyone in the chat, you can type, how would we create a... No, I want to create an object of type rectangle. Eh? Ooh, constructor. Or if we wanted to initialize the stuff, we would need a constructor, yes. But let's just think about initializing it. So what would I type in main here? Does anyone know? I wouldn't expect, because obviously you guys haven't programmed outside of the assignments. You haven't. Okay, cool. Yeah, that's correct. So we would say, almost, but close enough. It's also easier when you're actually typing in the code, definitely, because things are highlighted. We would do something like this, right? Rectangle rect equals new rectangle. Now, guys, what if I wanted to create something of type int? One of you in the chat, create a variable of type int. How would you do that? Int x equals 3. Yeah, cool. Good one. Int x equals 3 is cool. Now notice I don't have to set them equals to anything, right? I can set their value, but I remember we discussed this a lot earlier on in the course. Variables need two things, right? A name and a type, and they can have a value, but the value is optional. They don't need a value. Okay, so I've created two variables here, right? Rectangle rect and int x. Okay, int is a data type. Rectangle, you can see, is in the same. Remember how we create a variable? We would say data type and then name and then semicolon, right? Right, the name of the variable, I mean. Okay, data type name, that's sort of the template for creating a variable. Rectangle it's a data type that I created with the class. Okay, so this statement is true. A class is a definition of a new data type. Okay, a class defines the template for an object. That's basically the definition of a class, so that one's definitely true. And so that leaves us with this. A class is a concrete instance of an object. So why is this tricky? Because this is literally just the reverse of the truth. Okay. The correct statement, the true statement, would be an object is a concrete instance of a class. Okay, an object is a concrete instance of a class. That would be true. This is false. Okay, a class is not an instance of an object. An object is an instance of a class. Okay, so often these are the trickiest, where there's a grain of truth in the wrong answer. So concrete instance, just see it as instance. They're just being fancy. And an instance is just to say, I remember defining it this way earlier, but if I say rectangle rect equals new rectangle, what are we saying on this line here? We're saying in this instance, rect is an object representing a rectangle. Okay, so this is saying in this instance, I'm taking the blueprint defined in rectangle, and I'm creating it in rect. Okay, so the word concrete is literally just, it's not technical. They're not being technical. It's just like, it's specific. Okay, it's fixed. So the object is fixed to that class definition. Okay, so we're just saying in this instance, the object is a representative of this class. Okay, so another nice way of seeing it perhaps is if I was using rect inside rectangle, I would refer to it as this, right? When I say this, I'm like pointing at something, right? You could see it as concrete, right? I'm pointing at something specific. And so you're saying like in this instance, when I'm referring to this object, I'm speaking about rect. Okay, so we know what an instance is. They just added concrete there to be more technical. Okay, it doesn't change the meaning. Okay. So yeah, concrete instance, just see it as the same as instance. No difference. Cool. I did promise that we would stop there. So we'll review the remaining, how many are there? 1, 2, 3, 4, 6 questions next week. But yeah, so the object thing is quite nice, right? Because I'll put it one more way just before we stop. Look, so I can create multiple things of type rectangle, right? We've seen this before when we were creating compare to, right? I can have rect1 and rect2. So when you say rect1, you are referring to a specific object in this instance. Okay, like when I say rect1, I'm saying I'm referring to a specific version of a rectangle, right? The rectangle class is defining a type, an idea. Rect1 is making that idea concrete. That's a good way of putting it. It's making that idea concrete, giving it an actual form. All right. So that's when we create objects from classes. Okay. All right. Awesome. So yeah, let's call it there. There's one more thing I wanted to tell you guys to do. I'm going to post on the WhatsApp group a form. It's the MTA exam registration form. Okay, so it will allow us to book the test for you, which we are currently scheduling for November. Okay, so we'll schedule the test for the end of November, right, which gives us plenty of extra time to prepare and finish the remaining sections. Okay, so yeah. And so I'll post that on the WhatsApp group. Just fill that in, and that'll define, what information will go on your certificates and things like that. Cool. So I'll post that, and other than that, yeah, guys, enjoy the rest of your weekend. Thank you for coming. See you next week. Yeah, you too, guys.
Have a good day, sir. Thank you.
Yeah, you too. Cool. Cheers. All right.